Question number 7. Okay. So a block of mass 2 kg placed on a trolley of mass 5 kg. So therefore, this is your 2 kg mass, this is your 5 kg mass. Moving horizontally, a force of 8 newtons applied to the block. It slides on the surface of the trolley. 8 newtons is applied over here, and it says very clearly this 2 kg is sliding. Okay. The frictional force between the trolley and the ground is 0. So here the frictional force is 0. Frictional force is 0. Okay, fine. The trolley accelerates at a rate of 1 meter per second square, which means what? Trolley is not stationary. Trolley is also moving over here. Trolley is moving over here with a speed of acceleration of 1 meter per second square. Okay. The frictional force. Okay, what is the coefficient of dynamic friction? What's the value of mu? That's the question. Okay, so towards it, first let us have some basics. I think I'll take some more time to explain. Not so clear for some of you. So I'll take some more time. Okay. So you see, this 8 Newton force, what does it do? It overcomes the friction. It also is useful in moving this one over here. So what I will do in that case is I will say a force of F1 acts on this object and a force of F2 acts on this object, such that I can now say F1 plus F2 is equal to 8 Newton. This is the first basics I have built, right? Then the second thing is that let me analyze the free body diagram for the upper object alone. When I do this, what do I get? Let me write down the object separately. So this is your 2 kg. This is your 2 kg object, and you have a force F1 applied over here. That is 8 Newton, not F1. 8 Newton applied over here, and you have a frictional force acting over here, right? Let me call this frictional force as some x over here. You need not confuse. So what I will do is I will write this as 8 minus x is equal to the net force F1, right? 8 minus x equal to F1. Then in a similar way, if I consider here, now what will happen here? This is F2 is acting like this. F2 is acting like this. Net force F2 is equal to, now what is this F2 here? Is equal to m into a. What is m here? 5 multiplied by 1, which is equal to 5 Newton over here. 5 Newton here, right? Now what is F2? F2 is nothing but, from here I can say F2 is nothing but 8 minus F1, right? What I will do is I will substitute it over here. I will write 8 minus F1 is equal to 5. And what is F1? I will again take this one, put it over here, which means 8 minus of 8 minus x is equal to 5. So, which means what? 8 plus 8 minus 8 goes away. Minus into minus becomes plus. So, x should be equal to 5. Now, what is x here? Frictional force. Where does the frictional force act? It acts here, right? So, therefore, if I consider that this frictional force x is equal to, frictional force, I'll write here, frictional force x is equal to mu times n, because it is sliding friction, right? Mu times n, this should be equal to mu times, what's the n value here? 2g, because we need to just consider only the upper object over here. There's a friction between these two, right? So which should now be equal to 2g, which should be equal to mu into 20. Now I can equate this. I'll say x equal to 5, so 5 is equal to mu into 20, and mu should be equal to 5 by 20, which is equal to 1 by 4, which is equal to 0.25. The answer is C over here.